Next, let's take a look at the features and functionality that CAMWORKS Turning Standard includes. CAMWORKS Turning Standard includes all of the functionality included in SOLIDWORKS CAM Standard and Professional, as well as the functionality included in CAMWORKS Standard, and it adds milling and turning with multiple turrets, mill turn programming on multitasking machines, mill turn in SOLIDWORKS assembly mode, and the ability to add voluturn or prime turning by Sandvik. So now, let's take a look at CAMWORKS Turning Standard in action. Here's a fairly complex mill turn part we might want to program, and let's begin by asking, how long would it take to program this part using a standalone CAM system? My experience tells me it would likely take at least an hour, if not several hours, to program this part. But using CAMWORKS, we can program this part in only a few minutes. We'll begin in SOLIDWORKS assembly mode, where an assembly of the chuck has been added, along with the part and a piece of bar stock we want to use for machining. CAMWORKS is a fully integrated CAM system for SOLIDWORKS. Once CAMWORKS is installed, a tab is added to the SOLIDWORKS Command Manager, and 3 tabs are added to the SOLIDWORKS Property Manager. One for the CAMWORKS Tool Tree, one for the CAMWORKS Operations Tree, and one for the CAMWORKS Feature Tree. We'll start on the CAMWORKS Feature tab and open the machine. Here, a default machine has been automatically selected. Over on the Tool Crib tab, there's a list of standard tools we might want to use on the machine. A post-processor has been automatically selected, and the chuck assembly has been pre-selected, also based on the machine we selected. We'll say OK and move on. Next, I'll open the Part Manager and select the part I want to program in the assembly. Now I'll open the Stock Manager and select the piece of bar stock I want to use for machining. Now that we've selected the machine and stock we want to use, we can use Automatic Feature Recognition, or AFR, to automatically identify the machinable features on the part. CAMWORKS Feature Recognition is able to identify over 20 different types of machinable features on models, and in a few seconds, it will automatically add them to the CAMWORKS feature tree. Now that the features have been identified and added to the CAMWORKS feature tree, I can specify features I want to machine on either the main or subspindle. The OD of the part I want to machine using both the main and subspindles, so I'll select both. The same is true for the ID of the part, which needs to be machined from both sides using both the main and subspindles. This face feature is for facing the part on the subspindle, so I'll select subspindle for this one. Now that the features have been recognized and the spindle for machining has been specified, I can generate all of the operations using the patented TechDB, or Technology Database. Using the TechDB, you can capture your best practices, including the tools, feeds, and speeds you want to use for machining, and CAMWORKS will automatically reuse them to generate programs. Now that the operations have been created, I'll generate the toolpaths for machining. The next thing I need to do is add a subspindle operation to transfer the part from the main spindle to the subspindle. If I scroll down in the operations tree, right here is where I need to create my subspindle operation. I want to do a standard transfer from the main to the sub, and this little utility lets me control the exact movements and actions for both spindles. Here we can see the subspindle as it approaches the part. And I want to move the subspindle to the correct position before closing the jaws on the subspindle. The subspindle jaws will then close around the part. There will be a 5-second dwell. Then the main spindle jaws will open, and the subspindle will return to its home position with the part. Now that the subspindle operation has been added, I can use toolpath simulation to simulate the machining of the part. I'll push the run button, and here you can see the part being machined. First, the turning operations will occur, then the milling operations. Once the machining on the main spindle is complete, the subspindle will appear, and the machining on the subspindle will be simulated. Now that the simulation is complete, I can use the Compare feature to compare the machined model to the design model. Everything you see in green is machined net to the design model. If there was any gouging of the part, it would be in red. And where there is stock remaining is in blue. And you can see the wrapped pockets are in blue because they have not yet been machined. Some complex features can't be automatically recognized, but we can use interactive feature recognition to create them. I'll go back to the feature tree and use interactive feature recognition to pick the bottom of one of the wrapped pockets and the diameter of the top of the pocket. And that quickly, I've created a wrapped pocket feature. Next, I'll create a circular pattern of the pocket to create all 4 pockets around the part. Now that the features have been added to the feature tree, I can generate the operations for machining the wrapped pockets. And over on the operations tree, we'll generate the toolpaths for machining the pockets. Now we can again run toolpath simulation. And this time you can see the wrapped pockets also being machined. Once the simulation is complete, I'll again use the Compare feature. And now we can see the entire part is in green and has been machined net to the design model. So I hope you're able to see how quickly you can program parts like these using CAMWORKS Turning Standard once your TechDB has been configured. Next, let's take a look at another great feature that's available in CAMWORKS Turning Standard. If I go up in the operations tree, let's take a look at this roughing operation that does the OD roughing on the part here. And what we'd like to do is to use pinch turning to accelerate the rough turning and reduce the cycle time. So I'm going to edit the turning operation, the rough turning operation. And if I go to the Statistics tab, we can see the cycle time here is 6.69 minutes. So now, let's go over to the Turn Rough tab, and if I click on this box, you can see that the simultaneous pinch turning operation was instantly created. And now, using 2 tools to do the pinch turning, I can go to the Feed and Speed tab. And what I'll do is I'll go ahead and double my feed rate. Since I'm using 2 tools now, I'm able to increase the feed by 2 times. And now let me go ahead and preview it. And now we can take a look at the simulation of the pinch turning operation. First, I'll bring the part up to its current state and then begin to run the simulation. And here you can see the pinch turning occurring. So I think you can see how easy it is to add pinch turning to a roughing operation. And now if we go back to the dialog box and open the Statistics tab, you can see where my cycle time is now half of what it was previously, thanks to the pinch turning that I've added. Now, if you'd like to do more simultaneous machining, you're going to want to look at the CAMWORKS Turning Professional. So that about wraps it up for CAMWORKS Turning Standard. Thank you for watching. Now that we've looked at CAMWORKS Turning Standard in action, let's take a look at some of the features and options that are available for CAMWORKS Turning Standard. I'm going to use this chess piece as an example, and let's suppose that we want to machine this bishop out of 6061 aluminum. I'll go to the CAMWORKS feature tree, and I have a mill turn machine already selected. That's my default machine selected. And you can see the chuck here, and I'm going to set this part up on horizontally on a chuck like you see here. And if I highlight the stock, you can see the stock being held in the chuck. So let's go ahead and program the part. We'll start by extracting the machinable features. You can see that CAMWORKS very quickly finds the turning features that I need for turning this part. Next, what I'll do is create a couple of mill part setups, and these are to mill the slot. So I want to mill the slot that you see here in the part. I want to mill that halfway from each direction. So I want to create a mill part setup for the feature, and we'll select the top plane. You can see that is going to be the machining direction. So that'll be the direction where the M mills will come in to machine that slot. I'm going to say OK here, and then create that 2.5 axis feature. It is a corner slot that I'll be creating, and we'll use Sketch 3, and then select here to specify the direction for the depth of the slot. So 10 millimeters in that direction. And then I'm going to do the same thing essentially on the other side. So I'll create another mill part setup, and this one will also use the top plane but be in the opposite direction. And then I'll create that same 2.5 axis feature corner slot using Sketch 3, and this time we'll make it in the opposite direction, so it'll be down at the bottom of the slot there. Now that we have our setups and features created, we can go ahead and generate the operation plan and the toolpaths for machining. And this will take just a minute because I'm going to be using the VoluTurn for the roughing of this part. So, and there's another video that you can watch that's if you want to learn more about VoluTurn, but I'm going to be using that for the rough turning operation on this part. And so now let's go ahead and run the toolpath simulation so you can see how quickly I was able to program this part using CAMWORKS. And let me just rotate this view a little bit so we can see it a little better. And you can see that it has machined the part. If I compare the machined model to the design model, you can see here that everything in green is net to the design model, but you'll notice some blue here on the back of this flange. So if I go back to the turn finish, you'll see here where there's some material left on the back of this flange. That's because of the 55-degree diamond and holder that I'm using to do the machining. Now, in order to finish the back of this flange, I might have to add another tool in the opposite direction. That would require a tool change and more cycle time. But if you have a B-axis, there's a great feature that's included in CAMWORKS Turning Standard that we can use to remove that material. And that feature is continuous B-axis machining. So what I could do is open up this finish operation here. And this is using that 55-degree diamond to do the machining. And now you can really see why I can't get into the back of that flange there because of the holder. So what I'd like to do is to go to the Turn Finish tab and turn on continuous B-axis machining. And then what I could do is check my settings here, and then we can go ahead and select this radio button to adjust the angle as it moves through the profile. And now let's go ahead and preview the toolpath. And now you can see where that toolpath now is able to get in and machine the back of that flange. And if I go ahead and run the simulation here, you'll really get an idea of how that continuous B-axis pays off. So so now I'll go ahead and play that, and you can see the part, the tool and the tool path. Let me run it a little bit slower here, and let's go up to current, and this is what it looks like after it's been rough machined. And then I can go ahead and play the simulation, and you can see that continuous B-axis motion and how it's able to keep the tool tangent to the machining surface, and also how it's able to tilt the tool and get into areas that you would not normally be able to machine using that continuous B-axis. So you can see here where, and it's actually got clearance there. You can see where it's able to get into the back of that flange now and finish the part nicely. Okay, I'll speed it up a little. All right, and then if I compare the machined model to the design model, you can now see where everything is in green, and it looks like it's been finished machined nicely, finished turned. I'll say OK here. And then we can close out of the dialog box. So now that we have that finished turning done, you'll also notice here that there's a cutoff, but I'd really like that to occur at the end of the process. I don't want to cut the part off before I've milled these slots. So what I'm going to do is create a new turn setup on the main spindle, and then I'm going to move that setup down to after the milling, and then put that cutoff, and I'm just using drag and drop here to drag and drop that cutoff operation to that turn setup. Now that I have that complete, we can watch the simulation once more here. Notice that it's using that volute turn for the machining there, for the rough turning. And if I look at that rough turning for a minute, you'll see it there where that high-speed volute turn tool paths using a round insert is able to machine 2 to 3 times faster than conventional roughing, and it also extends the insert life by 2 to 3 times as well. So you could look at the volute turn video to learn more about volute turn. This volute turn is an option to the CAMWORKS turning standard. Okay. All right, so that about wraps it up. Thank you very much. For more information, go to www.camworks.com or contact your SOLIDWORKS or CAMWORKS reseller.